Hello, my name is Ganesh. I'm a partner solutions architect with the SAP team here at AWS. And with me, I have my colleague Kenny. We are going to show you how to build a customer 360-degree view using SAP and AWS. Now, this is the data footprint that we see with a lot of our SAP customers. They have their core applications. They're typically running SAP S/4HANA or BW on HANA, and they have a good amount of operational reporting and embedded analytics that are built in within the systems. But we also see customers having a number of SaaS applications. And we also see customers having a lot of devices and sensors that are continuously transmitting data that needs to be loaded into a data lake. And we see homegrown applications built typically in the Oracle or a .NET stack that also have a lot of business critical data. Now, all of this data needs to be extracted, transformed, and loaded. In this exercise, you will see how we use AWS Glue to transform and load data. And we also use SAP Data Services to directly connect to SAP to extract data and hand it in Amazon Redshift. Now, purely from a data lake standpoint, we see customers going directly to Amazon S3 because it's the most cost-effective, durable storage in the world today. And they use AWS Glue Data Log to catalog the data in Amazon S3. And from S3, you could actually use either our machine learning services like purpose-built services like Amazon Textract, Amazon Forecast, Amazon Recognition, or you could build your own models on S3 data using Amazon SageMaker. From a data aggregation and data warehousing standpoint, we use Amazon Redshift in this demo. And from a visualization standpoint, we use Amazon QuickSight and SAC as well. This kind of summarizes what we see with customers in terms of data footprint. There is also federation that could work with HANA as a virtualization layer, and Amazon Redshift directly works with SAP Data Warehouse Cloud as well. Now, some highlights about Redshift. We have tens of thousands of customers running their cloud-based data warehouse loads on Redshift. We have purpose-built hardware for Redshift. We are the most secure and compliant. And at a cost of $1,000 per terabyte, with even greater savings opportunities for reserved instances, Redshift provides a very compelling value to every enterprise customer out there. The second source data that we would be using is Amazon Connect. This is our cloud-based contact center. It has all of the features that you would expect in any contact center software. We also have Contact Lens for Amazon Connect. You have Kendra integration for search. You have sentiment analysis. You have automated contact categorization and several other features coming soon. And to use Amazon Connect, all you need is a headset. Everything else is managed by Amazon in the cloud. Now, typically, we have various strategies to ingest data into the data lake. For SAP systems, you have the data orchestration layer where you use ODP, and sometimes you use ODP and OData together. This is what we'll be using in this demo today, but we also have other approaches, like you can tap into the JCO layer and back into the ABAP stack into function modules, IDOCs, tables, views, queries. And you can also do database level extraction using redo log-based replication. We have a detailed blog that covers each of these aspects, and you will see data services and Glue in action in this demo today. With that, I would like to hand it over to Kenny, who's my colleague, and he would take us through the demo. Thank you.
Thank you, Ganesh. We will now see how SAP Data Services and AWS services work together to consolidate diverse set of data. In this architecture, we have used SAP Data Services to extract data from SAP to Amazon Redshift table. We have also used AWS Glue to transform your Connect data sent to S3 as a JSON format. Now, Glue will transform the data. With that transformation, you will be converting the JSON file into readable table format in Amazon Redshift and store it as an external schema. Once the data is available from Connect and SAP, you will consolidate the data and stage the data for Amazon QuickSight to provide you a visualization and deep insights of how and when the customers are calling and for what reasons the customers are calling. You can also tap into data federation layer to consume this data available in Redshift and Athena back into SAP using Smart Data Access. If you're using Amazon Analytics Cloud, you can also consume the data in S3 and Redshift. The data in Redshift can be unloaded to S3 and consumed using an open connector within SAP Analytics Cloud. If you're tapping into the Redshift layer, you can use a Apos Live connector to get the data into SAC for your visualization. Now let us see how to set a centralized lakehouse architecture using Amazon Redshift in a demo environment.
For this demo, first we need to configure a data extractor in SAP using RS02 transaction. This SCPM extractor is based on sales order header table. The next step, we create a project in data services and then we create a data store for that project. The first data store would be our source data store. You would input your SAP application server details to pull the extractor you created in the previous step, which pulls the sales order data into your data services. And once the source data store is created, you can input the extractor into your ODP object by right-clicking your source ODP data store that you created, and then you import by name, and then you can choose the extractor as an ODP objects to pull the data into your data services. The next step, you create a Redshift cluster and you'll copy the details of your Redshift cluster to go back to your data store and create a target data store in your data services. In this case, our target data store is named as target Redshift. And if you see the configuration, you go to your ODBC data source administrator, and to configure the data store, we have to provide the server details that we copied from our previous Redshift cluster creation. Once you input the details, you'll be able to connect SAP data services and Amazon Redshift. Once the connection is established, you can complete the data store creation, and as the next step, you can import the tables available in the target Redshift by right-clicking and importing the table name. To do this, we will create a Redshift table with the schema sales RS sales order, and we create a table similar to the schema that we used in our extractor. The attributes and the categories that we used in our SAP extractor. Once the table is created, you can go back to your target Redshift data store in data services and right click, and you would input the schema name and the order table, and you can import the order table into your SAP system, in this case SAP data services. The fourth step here is to create a data flow for your Redshift project that you created within your data services. You create a sales order flow, data flow in data services, and you would drag your source and target data store in your data services. And as a next step, you will start mapping the values, the field values between your SAP system and target Redshift database. You do this by doing a query transformation. As you pull the SAP fields into your data services, you can right click and map all the desired fields to your target Redshift fields that you use to create or you use to create a Redshift table in the previous step. So this is a Redshift table, and this is your source SAP data store. So you would map all your SAP data store fields with your Redshift table fields. Once that mapping is done, you can also use an optional query transformation in case there is kind of a special character errors. You can use a transformation function to remove any special characters while loading the data to Redshift. Once the data store is completed, you can then right click and submit a job for this data flow that you created. Once the job is executed, you will be able to see the data from source and target table is available. Now your data services configuration is complete. As part of this lab, we'll also bring the data from Amazon Connect. We assume the Amazon Connect sends the data to S3. In this case, the data available from Amazon Connect does have a custom attribute called SAP order. This is a JSON file sent to S3, and you would see a JSON file with a custom attribute as an SAP order. Now, since it is a JSON data, we would use Glue to crawl the JSON data and to create a catalog. And then once you crawl the data, you should see the data has been transformed and record has been created in your Glue. This particular transformation from a JSON to your readable table will allow you to load the table into Redshift to create a unified view. As a next step, you would create, now the data is available in Glue. Now you need to bring the data into your Redshift using an external schema. So you would create an external schema to load the data as a Redshift table from your Glue. Using this particular query, we are creating a external schema and loading the data that is sent by Amazon Connect, the data that we transform using a Glue into a Redshift table, an external schema. And then once you have a data from Glue and also a data from SAP into Amazon Redshift, in the next step, you can create a table with combining both Amazon Connect and SAP data together. So I'm using a sales order table here. I'm creating a sales order table by combining both the information from Connect and Redshift in this step. We call it as data modeling for our unified view. This is similar to creating a calculation view in your SAP system. We used external schema and then we created a data in Redshift, table in a external table in Redshift using your Connect data. And we already have completed the data services and Amazon Redshift connection, and we have loaded the sales order header table. Once we have done that, we are combining both the data by doing a data modeling and building a third data table for us to, create a view. And now, once a table is available, as a next step, you can create a view from your previous unified table. And then once your table is available, a view is available for you, we can actually run a query to quickly check if you can pull some records from that view that you created. So I'm using a simple select, and I need three attributes or three fields that I would like to pull. And I ran a select query, which produces the results. I'm limiting the count by 6. Now your data is ready for visualization. So we have a disparate data, one data coming from Connect and one data coming from SAP. Now, since we have combined this data and staged the data, the next step we can do a data visualization. Amazon Redshift and Amazon QuickSight can easily integrate. There are built-in integration available with QuickSight. You point the Redshift cluster and the table that a view that you want to pull. Once you pull the data, you can create a visualization based on your requirement. In this case, we want to know call duration by the customer, or call duration by the month, or even call duration by the product. This is one case where we can use Amazon QuickSight for visualization, but as a customer, if you have SAP Analytics Cloud, you can unload the data from Redshift into an S3. So you're unloading the view that we created to a Redshift. So from the Redshift to Amazon S3, that view is available for SAP Analytics Cloud to consume the data. So we have created a connection in Amazon between Amazon S3 and SAP Analytics Cloud. Once a connection is established, we can pull the data. Once we pull the data is available for your visualization. So we can load call duration by product. So in this demo, we demonstrated the tools and the various possibilities for a customer to consume the data and to extract the data and tie the data together between different systems and create a unified view to get end-to-end deep insights between your SAP sales order and the customer calls within your organization.
Detailed step of this demo is available in our SAP on AWS blogs. Please visit our AWS blog site to understand the step-by-step instructions. Thank you.